So the iGCSE loves to ask questions about terminal velocity, or even, which is usually a term that's reserved for objects that are in free fall, or it could even be some sort of constant velocity that's been reached. So, for example, a car or a truck or something, or a train that accelerates until it reaches a constant velocity. But terminal velocity is usually used for objects in free fall. And basically, it means that so when objects are in free fall, they will fall and accelerate at the beginning. They'll fall very quickly, and then eventually they will stop accelerating and fall at a constant velocity, which is called the terminal velocity. So terminal velocity, the idea is that usually when they ask about it, they want you to talk about the forces that are acting on something. So if you haven't seen the force diagrams video, you may want to watch that first. This is the paper from that, okay? And remember that so I'm going to explain this using force diagrams. And so remember that the size of the arrows in the force diagrams are important. So if the arrows are balanced, then the object is moving at a constant velocity or is staying still because the forces are balanced. The size of the arrows tells you something about the size of the force in that direction. Okay, so here the idea is this ball is in free fall. The arrow up was smaller than the arrow pointing down. So the idea is that the resultant force, the unbalanced force on this, is 20 newtons downwards. So when something is falling, right, the idea is that when it falls, this is immediately after dropping it. Don't worry, I'm not going to draw little people jumping from airplanes, even though this is how I usually talk about it, but balls are easier to draw. So it has the force that is acting on it immediately after being dropped is mainly the weight, okay, and that acts in a downwards direction, and it's constant because the weight of the ball doesn't change, all right? Now, but as it falls for longer, right, then it's going to pick up speed. So the idea is that at first, okay, when the ball falls, it's going to accelerate quickly because the only force acting on it is in the downward direction, and that's going to accelerate. So initially the acceleration is going to be the force of gravity, the acceleration due to gravity, which would be 10 meters per second squared. But as it begins to pick up speed, then there is a second force that begins to act on it. All right, so the idea is that the weight remains the same, so the arrow should be about the same distance, but as it picks up speed, okay, and so this is the idea that it's gaining speed here. As it picks up speed, then there's another force that acts in the opposite direction of weight, and that is drag or air resistance. Okay, and the faster the ball goes, then the more drag there is. Okay. So drag increases as the speed increases, which means that the longer the ball begins to fall, the bigger this arrow will become because it's going up, it's increasing, because you're going to draw a bigger arrow as the speed increases, until at some point the idea is that the arrow going down and the arrow going up will be the same size. All right, and so that means that the speed is now constant because the forces are balanced. Which means there is no resultant or unbalanced force. And if there's no resultant or unbalanced force, that means there is no acceleration. And we know that due to our little equation friend, F equals m times a, right? So if this is zero, the mass obviously isn't zero, and so the acceleration then has to be zero. So the idea is that when the forces are balanced, right, the drag equals the weight, there's no resultant force, and that means that there's no further acceleration, no change in speed of this ball, and so it falls at a constant velocity. And this is the terminal velocity. And it's the same idea if something is moving in a parallel direction. I'll do a short little video to talk about how that might look on a graph. But this is the idea of what you want to be talking about. And this is the key, is that as speed increases, then the drag increases. And so the resultant force gets smaller and smaller and smaller until the two forces are equal, and then the resultant force is 0.